Assalamualaikum and very good evening. Today I would like to present about the designation of high voltage ceramic porcelain insulator HVDC wet and dry test. For this presentation, we're going to present the simulation of the ceramic insulator using finite element method magnetic FEMM. So our company background is name is Faris Salim Sedia Berhad. Faris Salim Sedia Berhad is involved in manufacturing, distribution, and provider of electrical and electronic equipment used in high voltage transmission. As an engineering company, the main core for this company is on the high voltage direct current HVDC transmission system and component. The company is providing the HVDC products such as cable, insulator, supply of transformer and capacitor in the market and develop the new technology for monitoring power cable. So this is our organization chart. Our Ahmad Faris bin Saleh is our director. Nurliana binti Zulkifli is a production manager, and I myself Shazala binti Muharazi is a project manager, and Emmanuel Aran Anak Daud is a design engineer. Next, I will going to present the introduction. So for this project, we designed a stackable insulator for HVDC made of ceramic porcelain. So there are a few factors needed in considering a good insulator, such as its maximum reliability, its flexibility, its cost, the safety, and also the capability of withstanding the normal and abnormal condition of the high voltage. As for example, for the abnormal voltage is transient over voltage, where the transient over voltage is a sudden rise in the voltage due to the lightning strike and also the failure of the switching operation. So the lightning strike can be immediate, and it can damage the equipment as well as the component. So the insulator need to be able to suppress the high voltage from the lightning strike, from the sudden high voltage from the lightning strike. And we also need a good insulator to be able to withstand the inconsistent frequency from the switching operation. Next, the simulation of the performance of the insulator by using the FEMM analysis. We simulate the performance of the insulator by using FEMM analysis, and we got the graph for the voltage distributor and also the electrical field strength. Next, we evaluate the performance of the HVDC testing for insulator under wet and dry condition. For most countries in Europe and also in Malaysia, we follow the IEC 60071 standard, which is insulation coordination. The standard we strictly follow because of before the equipment such as installation of the transformer are able to operate in its service, we need to know its capability of to withstand the abnormal and normal condition of the high voltage.
Summary of chosen design. Overall physical concept. Insulators are needed in transmission lines to provide mechanical support and electrically isolate to the ground. In this project, suspension type insulator will be used. There is a sketch of 2D and 3D drawing using AutoCAD software. For material properties, we choose a high mechanical strength property so it can carry the tension and weight of the conductors. Next, we choose high dielectric material to prevent a maximum voltage that can cause breakdown. High resistivity to prevent the flow of leakage current from conductor to earth. Material with non-porous and free from impurities. Lastly, material that are not affected by the temperature. For electrical characteristics, the most important electrical properties are power factor, the electric constant, the electric strength, resistivity, and the influence of frequency and temperature. For mechanical and physical characteristics, we choose the brittleness, low tensile strength, high compressive strength, high temperature stability, chemical stability, thermal coefficient of expansion which average lower than metals, and low thermal conductivities. For environmental performance, depends on weather conditions, surface roughness, wettability, and insulator geometry. The presence of pollutants on insulator surface leads to different types of electrical discharge such as corona, particle discharge, and dry band arching, which results in the accelerated degradation of insulator material and can cause flashover and blackouts. This is the production cost. For minimum creepage distance, it is calculated 5,227 mm. For minimum clearance distance, it is 1,655 mm. For arcing distance, it is around 1,400 mm. For electrical data, lightning impulse wavetime, it is 800 kV. For power frequency wavetime, 390 kV. For mechanical data, specified mechanical load tension, it is 140 kN. For routine load tension, it is 60 kN. And lastly, for wet approximate assemble, it is 6.5 kg. This is the total cost for ceramic insulator, which is 4,005 ringgit Malaysia. This is the pros and cons for ceramic insulator. The pros of the ceramic insulator is harder than conventional structure metal, high melting point, low density, cheap, and extremely hardness. For disadvantages, it is dimension tolerance, is difficult to control during processing, easy to crack when hit with heavy item.
So, okay, I will continue with the methodology. So, at first we start, then we design and sketch the selected insulator using FBM software, and then we insert the type of material used for the insulator, and then we analyze the electrical field distribution and normal voltages until that we collecting data for the result obtained from the FEM software, and then end. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Faris bin Saleh, and I will presenting about the simulation and discussion for this project. This project use FEMM software to conduct the high voltage simulation for our insulator. We use 132 kilovolt that will be used for our simulation. So we can go to the next. You can see this is the voltage distribution for we conduct two simulation, that is dry and wet. So we can see the dry looks normal, and for the wet we have add one layer in each of the shed. So we put 20 degree Celsius of water every single shed, every single top of the shed. So if we can see the voltage distribution for the dry is looks really normal, like evenly spread from 132 kilovolt to the zero, that is the ground. So for the wet, we can see the impurities of the voltage distribution is not evenly distributed through the surface of our insulator. You can see the bottom is really different from this. We can see that it actually spread through the shed and then to the bottom, unlike the dry that went straight to the bottom. So for the wet, it go right to the far right before it go down. You can see this. So for the next is the voltage distribution. We how we get this is we take circumference the perimeter of this our insulator. Same for the wet, but for the wet we include water surface at the top, so it's the same but with water. So for the upper of water distribution on the dry, it should look like this, and for the wet it should look like this. So for the dry, the voltage is slightly uneven compared to wet. The where voltage slightly smooth. So the water particle that can form a pollution layer and might produce a leakage current, also give a rise to the flashover of power outrage for the wet. This can be prevented by applying a coat of ceramic porcelain insulation to reduce the risk of pollution flashover, which increase its reliability and efficiency. So we can see this is the dry. It look almost the same, but for the dry it's really have a really nice spike here, but for the wet not really a high spike at here, and for the rest of the graph it look almost the same, just almost the same. So next we go to the electric field. This is the electric field for the dry, and this is for the wet. We can see there's a huge difference for the dry and wet. For the dry, almost have many value from 0 to 350. So for the wet, almost cannot be seen, almost disappear at a certain amount of the length. So the electric field for this for the dry to from top to the bottom under dry condition, where the ceramic porcelain insulator might not suppress the result under dry condition to be condition. So in figure of the bed here, so with the higher voltage, the electric field intensity will be increased. This high voltage will break the insulation properties of air, and complete electrical breakdown will occur. The dry condition have a lower humidity, and the air surrounding the conductor insulator ideally being ionized. So ceramic porcelain insulator have suppressed the high resistance in wet condition due to the glass material, but inhibited slightly advantage over the dry condition. So that's all for the result and discussion from me. Thank you.
Last but not least, I'll present the conclusion. For the conclusion, the design of the ceramic porcelain insulator has met a few criteria of a good insulator. This has been proven by the performance of the insulation that have been verified by using FEMM analysis. Under the dry and wet condition, the ceramic porcelain insulator have been proven it work and have proven that it working well. Although the ceramic porcelain insulator working well in the wet condition compared to dry condition, this is because during the dry condition there have been less humidity, and the dirt particle might be surround the insulator and produce the pollution layer. The pollution layer will create the leakage current and also give a rise to the flashover and a power outrage. This is why the insulator are working well under the wet condition compared to the dry condition. Next, the high voltage testing are crucial for testing out equipment before its service. This is because the equipment such as transformer and also the insulator need to be able to withstand the capability of normal and abnormal high voltage before we putting out in the transmission line. And also we follow the standard of the IEC and also the IEEE to do the proper testing of the equipment before presenting it out in the transmission line. And last but not least, handing out high voltage testing must take all the precaution into account for safety purpose. Uh, the high voltage is very dangerous. The injury that happened during the high voltage is very unfortunate, and we might be able to do everything, do every precaution to suppress, to avoid any accident occur when handling the high voltage. That's all from us. Thank you for listening.